Good morning. This is Kasturi Day. Today I'm going to continue the discussion of hydrogen chapter question answer series according to ICSE syllabus class 8. Okay. So first I'm starting today is give reasons for the following. Okay. So first is hydrogen can be used as a fuel. Why? Because it has a high heat of combustion. Okay, because hydrogen has a high heat of combustion, it can be used as a fuel. Though hydrogen is lighter than air, it cannot be collected by downward displacement of air. It is so because a mixture of hydrogen and air can lead to an explosion. Okay, as hydrogen burns in air, so it can lead to an explosion. Okay. A pop sound is produced when hydrogen gas is burnt. It is because hydrogen, which we find, it's not pure. It has some impurities in it, and that leads to the pop sound. Okay. Hydrogen has replaced this helium has replaced hydrogen in weather observation balloons. It's because hydrogen has an inflammable nature. Okay, it has an inflammable nature, that is it burns in air, and that's why it has been replaced by helium in the weather observation balloons. Then nitric acid is not used for the preparation of hydrogen gas because nitric acid is a strong oxidizing agent and it oxidizes hydrogen gas into water. Okay. Now, next question is name the following two metals which have hydrogen, which give hydrogen with cold water, sodium and potassium. Then a metal which liberates hydrogen only when steam is passed over red hot metal, that is iron. The process in which oxygen is added or hydrogen is removed, it is reduction. I'm oxygen is added or hydrogen is removed, then it is oxidation. It's not reduction, that's a mistake. Please rectify. It is oxidation. Oxygen is added or hydrogen is removed, then it is oxidation process. Okay, please forgive me. A metallic oxide which can be reduced into metal by hydrogen, it is oxide of sodium. Name the chemicals required to prepare hydrogen gas in the laboratory. First is granulated zinc, which reacts with dilute sulfuric acid or dilute hydrochloric acid. 3. Metals which in red hot state react with steam to liberate hydrogen gas. First is magnesium, zinc and iron. Okay. So magnesium reacts with steam to form magnesium oxide and hydrogen. Zinc reacts with water to form steam to form zinc oxide and hydrogen. Then iron reacts with steam, red hot iron, that reacts with steam to form triferric tetroxide and hydrogen is liberated, though this reaction is a reversible reaction. Then 4 metals which react with caustic soda and caustic potash solution on boiling and liberate hydrogen gas. Those are zinc, aluminium, lead and tin, SN. Okay, tin. They liberate with caustic soda or caustic potash, react with caustic soda or caustic potash, and they liberate hydrogen gas on boiling. So zinc with sodium hydroxide, that is caustic soda, it reacts on boiling, it forms to liberates zinc, sodium zincate and hydrogen is liberated. Aluminium reacts with caustic potash solution to form potassium aluminate and hydrogen is liberated. Then lead reacts with sodium caustic soda solution, aqueous solution of caustic soda, to form trihydrogen plumbate. Okay, trihydrogen plumbate to form and it gives hydrogen. Okay, then tin reacts with caustic soda solution to form sodium stannate and hydrogen is formed, or it reacts with sodium hydroxide, only sodium oxide, not with water, then it gives sodium stannite. Okay, and hydrogen is liberated. Then two metals which react with dilute sulfuric acid and dilute hydrochloric acid to liberate hydrogen gas is magnesium and zinc. Then zinc reacts with sulfuric acid to form zinc sulfate and hydrogen. Zinc reacts with hydrochloric acid to form zinc chloride and hydrogen. Magnesium reacts with sulfuric acid to form magnesium sulfate and hydrogen. Magnesium reacts with dilute hydrochloric acid to form magnesium chloride and hydrogen. Okay, now we come to some study questions. Okay, so first one is briefly describe an experiment to prove that water contains 2 volumes of hydrogen and 1 volume of oxygen. When electric current is passed through an acidulated water, that is, what is acidulated water? Water which contains a sulfuric acid in it. Okay, so when this type of water is used and when electric current is passed through this type of water, acidulated water, then it splits into, water splits into hydrogen and oxygen. Okay, so this is the reaction. See, 2H2O which remains acidulated when electric current is passed through, it becomes 2H2 plus O2. A voltmeter is fixed with a platinum electrode. What is the process? I'm telling about that. Okay, a voltmeter is fitted with platinum electrodes. Acidulated water is passed in it. Okay, then acidulated water is poured in it. A voltmeter is there in which acidulated water is poured. A voltmeter which has platinum electrodes are there. Then two test tubes are fitted with acidulated water in inverted test tube. Two test tubes are taken which are filled with acidulated water and they are inverted over each electrode. When the current is passed from the battery, it decomposes into hydrogen and oxygen. H2 gets collected at the negative electrode, that is at cathode, and oxygen at the positive electrode, that is at anode. The ratio will we find is H2 is to O2, that is 2 is to 1. See, this is the voltmeter. See the picture. This is the voltmeter which has platinum electrodes. These two are the platinum electrodes, and the two test tubes are inverted, which are filled with acidulated water. They are inverted over each electrode. Then what happens when electric current is passed through this one? We see that hydrogen gets collected in this cathode and oxygen gets collected at this anode. Okay, so this is the electrolysis of water that is taking place. Okay, that shows that the ratio by volume of hydrogen and oxygen which gets collected, that is in the ratio of 2 is to 1. Next we come to, by drawing neat diagram, explain how hydrogen gas is collected in the laboratory and what is the importance of copper sulfate solution in the above reaction. So for this reaction, we take a clean conical flask in which about 5 grams of granulated zinc is added. The mouth of the flask is fixed with 2-holed airtight stopper. Through one hole, a thistle funnel is passed, and through the other hole, a delivery tube is passed, whose one end is dipped in a trough of water and covered with a beehive shelf. Okay, about 2 cc of copper sulfate solution is poured into through the funnel, and then sufficient amount of dilute sulfuric acid is poured in the flask in such a way that the lower end of the funnel is completely immersed in it. A brisk chemical reaction takes place and hydrogen gas is evolved that bubbles through the water. The first few bubbles of the gas is allowed to escape and then it is allowed to collect. Okay, because these bubbles contain air and that's why it is not collected. First few bubbles are not collected. Then a gas jar is completely filled with water and that is inverted over the beehive self, and the hydrogen gas will displace water and collect it over the gas jar. See from the picture, see a clean conical flask is taken in which we have kept some granulated zinc. Okay, see this flask is fitted with a cork which has two openings, 2 holes in it. From one hole a thistle funnel is put is inserted, and another another one, a delivery tube is inserted, which is the other end of the tube is put inside a trough which contains water. Okay, and this the in the trough we have put one beehive shelf which is inverted over the delivery tube, and over the beehive shelf we'll put one gas jar which will be filled with water. Okay, now what we do, we have put some granulated zinc in the conical flask. Now first, through the thistle funnel we will add some copper sulfate solution. Okay, and then that is 2 cc of copper sulfate solution we will add, and after that we will add sufficient amount of dilute sulfuric acid in such a way that the bottom of the funnel will be completely immersed in that liquid, that is in the dilute sulfuric acid. Okay, next is after some time we'll see there's a brisk reaction taking place, and the gas is being evolved from the reaction. Okay, that gas will come through the delivery tube and will start liberating out of the beehive shelf. Okay, so we will see this by formation of bubbles. Okay, through the water we will see some bubbles are coming out. So we will first let some of the few bubbles of which are first few bubbles to escape, that because it contains air. Now after liberating some few bubbles, escaping of the few bubbles, we will cover the delivery tube with the this gas jar which will be filled with water. Now this gas jar which has water, that will be displaced by the water will be displaced by the hydrogen gas, and it will get collected over the water. Okay, see here the hydrogen gets collected. So this will be the laboratory preparation of hydrogen. Now why copper sulfate solution is added? Because it acts as a catalyst, positive catalyst in this reaction. It will enhance the reaction faster, rate of the reaction. Now state 5 physical properties of hydrogen gas. Okay, it is a colorless, odorless and tasteless gas. It is the lightest element. Its vapor density is equal to 1 as compared to the air, whose vapor density is 14.4. That means hydrogen is lighter than air. That's why it will go above the air. Okay, it is sparingly soluble in water, that is 100 volumes of water can dissolve only 2 volumes of hydrogen only a few hours, after a few hours. So that's why it can be collected over water. Only at minus 240 degrees centigrade and at 20 atmospheric pressure, hydrogen can be liquefied into a colorless liquid. It is a non-poisonous gas in nature. Okay, so I'll stop here. I'll continue with the rest of the question answers in my next video. Please go through this one, and I request you to please go through the text videos for understanding the chapter much better. Okay, still if you have any doubt, please do write in the comment box, and do press the like button and share with your friends so that they can also be benefited from these videos. And please do subscribe, okay, to get the notification of my next video, and that will encourage me to produce you good videos for you, and so that can benefit in your studies. Okay, thank you for watching. Have a good day.